Hey everyone,
Hi.
we're gonna give you guys a couple of minutes to answer this Slido. So we have context. The question really just means, do you join meetups that are organized by communities outside of Malaysia? For example, BCKL is organized by us in KL. We're wondering if you also join meetups from outside of KL, like the guys creating the meetups from Singapore or Thailand.
Hazik, you
Hello.
haven't introduced yourself.
Sorry, always tend to forget. I always assume people will remember me from the comments. Anyways, guys, as Winnie has helpfully reminded me, I'm Hazik, one of the co-organizers for Data Council. First time in front of you all here. And I hope you all remember my partner here, Wendy.
Will be
Always
your co-host for tonight.
Yep. Hopefully you all enjoy it. Ooh, interesting numbers, actually. I was actually expecting it to be more one-sided. I mean, no preference or which one-sided, but I didn't know it'd be so split equally actually in Malaysia. What do you think, Warnie?
Maybe it's because when I was thinking about this question, I realized that I had to stop and think whether conferences that I joined were actually Malaysian or non-Malaysian. Because it's hard to differentiate in the virtual world at this point. It's just sometimes it's the time difference that tips you off. But other than that, usually it's okay, we're all virtual anyway, so it's all connected. But yeah, most people have though. So please,
Quite surprising. I personally think I haven't, or I think yeah, you're right. I don't know. I have to actually.
Yeah, see. But definitely more online events.
I see. Someone already calling me out.
Yeah, Hazik is just assuming that everyone knows him. Just hi guys, it's me.
Gotta have a little bit of sass, right? I mean, at one point you all will get to know me. Usually I'm there with them commenting, but today I'm here up front. So
yeah, you're there spamming us. Okay, so let's move on from the polls then.
Right. So just a brief introduction for everyone who's joining us for the first time. Basically, Data Council who have joined us before, we are split into four main parts, especially for virtual. The first part, we talk about Data Council, what we do, and a bit of the sponsors, and a very brief intro, just in case people don't know enough about us just yet. And then we cover the second section, which is the data dump. Third, we go into the talks by the speakers, and we end with a Q&A. On top of that, specifically for the virtual sessions, we also have an after session Zoom call or chitchat after, so you guys can socialize. And that one will be the one that's not recorded, so you guys can be a bit more free in how you interact with each other. So that's always important, right?
You can share everything.
That's what we want to hear.
So running through some housekeeping rules, please say hi, interact, react, ask questions in the YouTube comments. I see some of you are already quite active there. Thank you for that. We can't see each other now, but at least this will make things livelier and way more fun for everyone. Please participate in the poll Slido. This week, we kind of want to know what your virtual meetup habits are. Note that this live stream will be posted in this YouTube channel week. So important links will all be in the description box below. So now moving to sponsors.
So as usual, we love to shout out again and again to EngineersMY for always being sponsors. The StreamYard that we're using is given to us by EngineersMY. Always appreciate them, very supportive of the community. So you all just remember that name, guys. They're awesome. So for today specifically, we have another sponsor. So I don't want to say too much. They're IBM, they're awesome. But we have someone from IBM to share a few words. I'm gonna bring in Tim to the stream.
Hey guys, good evening. Hey, from San Jose, California. How are you guys doing?
Good morning.
Good morning for us. Yeah, I just wanted to pitch the IBM data science community real quick. We're a digital space for data scientists and AI developers, machine learning engineers. It's a space for data scientists by data scientists, and we offer lots of resources and learning. And you should definitely check it out. And right now we have a little promo going on. So if you join, you get a 1 month of complimentary IBM courses on Coursera for free. Yeah, definitely give us a look, check us out, and hope you have a great event.
Yeah, thank you, Tim. So we'll catch you hopefully in the Zoom call after this, right?
Yes.
All right.
Yeah.
See you
See you
then.
later. Okay, thank you, Tim, for dropping by, and happy learning, everyone. So now we're going to do a quick intro to Data Council for those who are first timers here. So Data Council is a company that runs data conferences worldwide. We're currently 1 out of 14 communities across the globe. And DC's main conference happens about 4 times a year across multiple countries. Our favorite thing about DC is that they are known for their no bullshit mantra. So we're aiming to cut through the hype and talk about real struggles that we all face. Do check out some videos on their official YouTube channel for past content. They had an exciting one last week where they covered Lyft's data catalog tool. So zooming into DCKL, we are DCKL, Virtual KL. Instead of waiting for the main event once a year, local chapters here can have more frequent meetups like these to keep the community close and active. Thank you so much for participating and being with us so far. Let's see. We wanted to use this platform as a way to level up our data community. So what we do is we bring together companies in KL and sometimes beyond KL, especially for virtual, to share their data journey and practices. So we did 4 last year. We did 2 virtual ones this year, and we're super, super grateful to have companies like Imagine, Money Lion, Reg Ang Pao, and now IBM support us with their speakers and venues. You can also check out the past event recordings at this channel. So to keep the community engaged during MCO, we also have a virtual edition for our talks. We've done 2 so far, one with Imagine and the other one with Money Lion on DBT. Hi, BK. Hoping to continue this momentum. So just to share, our virtual meetups have a little, the format's a little different. It's shorter, and we usually only cover 1 topic per session, and it's done more frequently. Again, today we also have a special post-event hangout where you can ask the speaker anything or ask the team anything, so please do join us later. So here's another question. Oh, that was fast.
Yeah. Oh, that happened before we pointed it out. So anyways, of course, we just wanted to really know whether people in the community actually go for all these data conferences. And I guess the follow-up question to this would have been actually, do you get your companies to pay for it, or do you go by yourselves? Yeah, honestly, it's a bit tricky. Controversial, sure, but I probably would have to admit that I actually have never been to a conference in Malaysia.
Really?
Yeah,
So you
no.
don't get like hotel food? You don't enjoy the aircon and the beanbag sometimes when you're trying to be informal? It's fun. That's how I've met like some people here. It's now we can also attend like different virtual conferences as well. How's it?
Yeah, I'm sorry. The others going on in the background, so it's a little bit noisy for you guys. So I have to turn off the mic for a bit. Yeah, but I'm enjoying the numbers though. I'm looking at a lot better respondents than the last few we had, right, Wenyi?
Yeah, I think people are just like tuning in. It's very interesting. Like, when have you guys been attending these data conferences? Aren't you guys supposed to stay at home? Like, that was the first thing. Like, I can't remember the last time I went for a conference. I think it was 20. Wow, it feels like a lifetime ago when you're allowed to go out. But yeah, thanks for answering and participating. We'll start the data dump now. Hazik, do you want to take this, or should I introduce them to our very
You're gonna have to
popular?
do it while
It's
I'm
okay.
going.
It's okay. It's okay. Yeah. So data dump is basically a series of like content and resources that is curated by our community. So it's things that the community finds cool, interesting, and directly applicable. So this is usually like our favorite part of it, because this is the part where you get content that like has been passed by a few data scientists, data engineers who were like commented. So let's invite George to the stream, our superstar, George Wong, who would take us through the data dump.
Hi everyone, I'm George, and I think I'll take you through dump today. Great to be back here again to bring you another data dump series. Fire away, I guess. For the first data dump, we have is 9 key machine learning algorithm explained in plain English, where breakdown k-means, recommender system, linear regression to layman terms where you and I could understand, even your business stakeholders could understand. I really recommend this for young data scientists and aspiring data scientists. I guess the next one. Boring data science. Yes, I always advocate for software engineering way in doing data science, where this entire blog talks about it teaches a simple way to bring software engineering and DevOps aspect into data science. If you think that this is what you like, take a look at it. It is also available on free code camp for the last article. Do check out this one too. And yeah, the next one. Yes, Beyond Unicorns. So this is written by Thomas Davenport, the guy behind the article, the sexiest job of the 21st century. So he brings in about business data science, and this is on Harvard Data Science Review. I don't want to spoil any of it. You can check it out and see it for yourself to see what is he writing, and yeah, do check it out. Efficient Python, PyTorch. If you've been dealing with PyTorch or using it and you find it hard to be efficient, I think you can check out this article as well, where he talks about ways that you can eliminate bottlenecks like and how the accuracy and set out his advice is really help. Thanks. The next one. And if you're a data or and I hope it also helps you a lot in really do.
Oh no, did we lose George?
Yeah, we lost him for a bit. I think the connection was a bit buggy on that one. Yeah. So let's.
But you're back at least.
It's gonna rain pretty bad, so I don't know about the background noise. Yeah. So we sort of dropped him for a bit.
Okay, do you want to bring him back, or should we cover this?
I think we should just go with it. Let's go with it. I mean, we can't
Just
foresee
go with
technical
it.
difficulties. Yeah.
Yes, let's introduce like cool data science resources. So, okay, deep note. So this is a different kind of data science notebook. If you guys are familiar with like Jupyter, is Jupyter compatible, and then it also has like real-time collaboration. Oh, and so this is the part. I like how they always feel the need to note this, that it's free. Besides that, you can always like connect it to like Postgres SQL or your MongoDB. So this is an alternative for your like Jupyter notebooks, and it can give you, you know, more kinds of information when it comes to, you know, displaying and virtual visuals. Sorry, visuals. So this one, I don't know if you guys are familiar with. Oh, George is back.
Hey,
Thanks,
sorry,
George.
I'm back.
You'll be a much better
Sorry,
person
guys.
to cover this content.
I'm so sorry.
But yes, do you want
So,
do you want to run through like Deep Note again? Because the way I explained it is like a different version of Jupyter. But go ahead, go ahead.
can you actually touch on a few points where it's free and some of it also allows real-time collaboration between data scientists, and I find it very beneficial for teams that actually, so you don't share notebooks around, but you actually collaborate with each other through this. And it also connects to Postgres, SQL, and MongoDB with ease. And do check it out. Right now, it's still, you can put in your email and
Still free.
there was an invite, so you can try it out. Feel free to try it out. Yeah. Next one. Right. So this article is by someone working at Cortex, where they were actually using Flask as a way to build APIs and to using Fast API. And I don't want to spoil any of it as well. Do check it out on why they provided their justification in using Fast API as a way to build for production machine learning. So yeah. Right, beyond pandas. I use pandas a lot, and I'm also thrilled that there's also other technologies in the field where we can use like Spark, Dust, or Vex. To be honest, this is the first time I'm hearing this, and I guess people should check it out too. And in this article, they compare different technologies head to head, and by comparing using billions rows of data and see their performances. If you are curious, check it out as well. Maybe you might switch the technologies that you are using right now to another one. Yeah. What I learned, right? Chip Huyen, she's no stranger to the data science field. Yeah, I like what she writes a lot, and yeah. So this time she brings 200 machine learning tools that she perhaps you can see what she writes and how she feel about it, and a lot of it I've not seen before, and I'm really excited to actually do this kind of thing, like reviews for machine learning tools. So yeah, do check it out. Hope you find it useful. Next one.
Okay.
All right, that's the end.
Yeah, that's the end of the data dump.
Yeah. Thank you,
yeah,
George.
Yep. She has.
Yeah, we'll catch you later, George. Yeah. So, topic we would like to cover. Interestingly enough, for this one, we just really want to know what you'd like us to actually cover in future iterations of Data Council. Because, you know, it's always nice to hear back from the community, and it's always good to get feedback so we can always give you a better experience when we're doing all this. So I'm not sure, is the Slido working well right now?
Yes,
there we go.
Yes, I see something. Please feel free to add as many as you can. I see there's a lot of like love for different kinds of tools in the YouTube comments. Yes, we love Postgres as well. Okay, that's always good that like API documentation is like complete. Thanks, Chi-Leong. And there's a lot of people hearing about Wex for the first time.
Oh, guys.
NAS is just like anything but DAS.
Ooh, someone put up Spark. I think we covered Spark before in one of the editions of Data Council, right, Wendy? I remember that one.
Yes.
I think.
It's okay. If we like people like it, we can always do it again. Data science and engineering in different companies. And teams of blockchain. I don't know enough about blockchain to comment.
I mean, It seems usually it sounds like too much of a solution for a problem, but I'm pretty sure it'll be great to see practical applications of blockchain. Ooh, hands-on demos.
Where's DCKL 2020?
Oh, we got called out on that one. Winnie, do you have an answer for that one? I don't.
Wait, I was gonna pass it to you. Don't put me on the spot. This is the toughest question ever.
But no, honestly,
We will tell you. No, we will tell you during the post-talk socials. Yes, that
yeah,
is what we'll do. So please
that is
join us
our
later.
official answer for
And
that
then
one.
yes. And the non-recorded version of this, we will tell you when DCKL 2020 is coming. Oh, governance. Yes, demos, newbies. Okay, this is cool. Like the list is increasing. But yeah, feel free to continue. It's very interesting to see like the types of topics you guys would like. Wait, has anyone mentioned AI yet? Nobody? I am shocked.
It's because we're covering AI today, so they can't ask for AI when we're talking about AI, right?
Yeah. Again, like challenges and ecosystem. Okay, cool. Let's like think of like people who could potentially cover this topic. I think Hazik, you can cover like 90% of it. We'll just like, add this to the list and say like today, even though we say we'll do one topic per meetup, today Hazik is gonna just do 10. He's just gonna like go through your wish list and just speed through it. Yeah, kind of like a extended data dump session where he covers all of these topics for like 10 minutes each. Someone said AI is overrated.
Ooh.
No comment. Oh, how to create a data catalog. Oh, that one you can find in DC SF. Is it SF? No, the main data council. There are a lot of like tools about like data discovery nowadays that are very interesting. The way that they think about how they want to structure data and how they want to make it easier for teams to go past it. But yes, okay, I will move on to a reminder.
Just a casual reminder. I said it before, I'm saying it again. Please feedback on every session you can. Tell us what you like. Tell us what you didn't like. Tell us what you'd like to see. Because, it's always
Not
better
us.
to make... I'm pretty sure part of the comments will be, let's never have Hazik as a host ever again. So, I'm just waiting for that
both
one.
of us.
Yeah, we're banned from this anyway.
Yeah.
Totally banned.
But yeah, so do tell like the organizers this as well. Say like switch hosts. And like how we like this to be conducted better. So moving on, please like enter the QR code now and start filling it in. Even pre-talk, we'll appreciate it a lot.
Yeah.
For the main event. So please welcome Austin. We can't clap, but yes, clap for Austin, who will cover explainable workflows using Python. So Austin is a data scientist from IBM on the technical marketing and evangelism team in SF's California. So it's kind of like 5 a.m. for him now. I'll allow him to introduce himself. Hi, Austin.
Howdy, thanks for having me. Good evening, everyone. Yeah, so like Warren said, I'm a data scientist. I'm in San Francisco, California right now. I guess just like a little bit of background for me, I have a master's in computational science from Florida State, where I did my thesis. And now I'm at IBM, and I'm here to talk to you guys about explainability and AI. Awesome.
Okay, so Austin, the way this goes is we're gonna leave you here. So for you and we're leaving you and your slides. So yes.
Okay, I'm gonna pull up my slides.
Show me away, Hazik.
Yeah, yes. Okay, we're going. I'm going first.
All right. Awesome. Well, I'm gonna set my timer so I don't go over time. But once again, thanks everyone for being here. I know it's pretty late in the evening. But I'm glad you guys are excited to hear about this. So let me get my timer started and I'll share my screen and we can get this going. All right, cool. Everyone can see my screen. All right, cool. So let's get this started. So today we're here to talk about explainability and what that means in data science and what an explainable workflow is. I just want to preface this is going to be a very high level overview. So I'll be here for the post-talk session. So if anyone has any more specific questions, I'll do my best to answer them. And the other thing is I don't have second monitor capabilities right now. So unfortunately, I won't be able to look at the chat in real time. But that being said, once I'm done with the talk, I'll address any questions I can, and I'll leave my email in case anyone has any follow-ups. So let's get into it.
Hold on there for a bit. I'm just gonna adjust the screen because I think the screens are popping up.
Oh,
yeah,
it's not there.
Yeah. So I'm just gonna check out what's going on actually.
Is it there now?
Oh yeah, I think yep. Now I can see it.
Okay.
There we go. Say bye-bye to me, baller.
Okay. All right. Sorry about that. That was a false start, everyone. Okay, cool. So now we can get into it. All right. So I love to start with this slide because it kind of sets the tone of what we're really going to talk about. So there's a popularized quote by Mark Twain. So there's three kinds of lies. There's lies, there's damn lies, and there's statistics. The reason we include this is because as someone who deals with data and numbers and with data in general, there are ways to display and serve things up where you can really change the perspective. So you could tell someone you have 90% accuracy, or you could tell someone you have a 10% failure rate. Those imply different things, and often times than not, the way you display that information is going to impact the way people perceive it. And we'll see where that impacts explainable workflows. A really popular one from George Box, I'm sure you've all heard, is all models are wrong, but some are useful. As a data scientist, it's not only your job to turn information into intelligence, which is actionable and usable to your business, but to also understanding the linchpins of the assumptions you're making on behalf of data and models. And then the last one is, why did you do that? And that's what I'm serving explainable workflows to circumvent is you don't want to be a data scientist in isolation working on a project that changes, and then you're asked, why'd you do that? And you don't understand where your work fits into the overall scheme of things. So with that being said, that kind of lays the groundwork of how we're going to address explainability. This is going to be a less technical talk. We're not really going to focus on the math or the mathematical assumptions of these models or why they work. We're really going to talk about how can you incrementally transition your current data science routine into one that is a little bit more transparent and hopefully overall more trustworthy. So this is so why are you here? You're here to learn how to adequately interface with stakeholders and explain to them what you're doing. This graphic by no means is a global view of explainability, but what it demonstrates is this is a primary output that you could use to demonstrate a deeper understanding of your pipeline, your algorithm, and how your data impacts classifications or predictions. I'm not going to go into this picture too much because I'm going to explain it further down the line, but really what this is saying is this is giving you the log odds for a binary classification, which is if we have two classes and we classify against each other, it's binary, so it's 0 and 1. And then if you look at these, this is basically just feature contribution. So this is like a pretty robust packaging of showing you feature contribution values as well as your the probability of that class being selected. But once again, we'll go a little bit more detail at the end. Okay, so this is from the XIA DARPA paper, which came out in the end of 2017 and why did my slide just disappear? Sorry about that. I'm not sure why that happened. Yeah, so this graphic is once again from DARPA.mil. It's the XAI 2017 talk where the defense agency in the United States government, and basically they allocated around $6 billion to different academic institutions to study explainable AI because what they realized is that the major impediment to successful deployments isn't necessarily the creation and curation of technology. It's actually the facilitated understanding of the end user and the stakeholder. That seems to be the largest limiting factor. And if you look out into the market, you can see indicators of that. So IBM just disavowed the use of facial recognition, and then they were followed by, Amazon and Microsoft. I'm not sure if you guys saw, but recently a neural network came out that's modeled after StyleGAN, which is a general adversarial network. It's called Pulse. And what they found is it was taking images of individuals, and what it did is it would take pixelated images and output an unpixelated image. But what would happen is they would put in non-Caucasian pixelated images, and they'd always come out with Caucasian features. And not only was there market feedback saying, hey, we're not a big fan of the way this is treating images, but the second and tertiary effect was no one was able to determine why this was happening. There was a few ideas behind it, like, was the data biased? Were the researchers writing the algorithm actually biased? Are there mathematical assumptions being made that are biased? Or is this just how the algorithm works? And that's kind of where this workflow will serve you, because when certain aspects of your data science routine come under scrutiny, you can think of explainability as a way to circumvent, hey, you did that wrong. Because if you can adequately explain what you're doing, you may have made the wrong choice, but I would say you're much less likely to be determined in the wrong. It may just have not been, the best bet. So this image, what it describes is, today we currently do training data, some kind of machine learning process. We learn a function, and then the end user's left with, why did that happen? Why not something else? When does it work? When does it not work? Can you trust this output? And so if you look at the today part of this image, that kind of is reminiscent of recommendation systems. I know we saw that in the data dump. When you're on Google and you get recommended a washer and dryer, are you able to adequately determine why? If you ask the ad agency why you recommended that, they could tell you the linear algebra and the algorithms they use, but could they, systemically tell you from this website to this website, that's what led you to getting a washer and dryer recommendation? I would argue that's unlikely. Versus the explainable interface, the idea is to add not only an explainable model, but some kind of interface that allows people to gauge why we arrived at the outcome we did. And also what it really wants to address is with an explainability interface, it allows you to better gauge, the limitations of some of these AI solutions, because AI and data science are by no means a panacea. They can't, data science isn't going to fix bad engineering, and it's also not going to fix, poor data initiatives. But what it will help you augment is a more efficient and equitable workflow, so that way you're not having to do redundant work. So the next step for me is, this is kind of canonical, but I think it's important. A lot of times people will lump together the terms interpret and to explain. And so what I did is I just went to the Merriam-Webster dictionary and I found the definitions of each word, and they do straddle and overlap, but I would argue that they are very much different to the extent that interpretations are static. And what I mean by that is we do our training data, pre-processing, what have you, feed it into the model, and we get some kind of output. We can render that output and, cross entropy loss, accuracy. We can get a confusion matrix and find out our true positive rate or false positive rate, all kinds of things. But the idea being is you solicit this output from your model, and then you interpret it. And then you do with that what you please. So I achieved 72% model accuracy. What does that mean to you? Well, I know and this is where as a data scientist, you kind of lean on your experience, or you go and talk to other data scientists, or do, online research. But, an example of interpreting is, hey, I used a decision tree, and on similar numerical data sets, people are able to get 88% accuracy. I got 72% accuracy. So that leads me to believe that I am doing some kind of pre-processing step wrong. And although that's not directly an explanation interface, what that is through, good coding practices, compiling good readmes and things of that nature, you can iteratively figure out why your model's not giving you what you expect. And that being said, it's not always in good taste to go into these modeling endeavors with an expectation, because sometimes it's just not going to work. But that being said, high level, interpret is a static evaluation of your model's outputs. Yeah, and then so explain, the part of this I really want to focus on is it's to make known. It's simply that. So, and I view explainability as the dynamic process of shuffling through these outputs and model parameters and things of that nature. So if you're statically interpreting what's happening, then you can dynamically explain it. So as you iteratively loop through, that example where we got 70-something% accuracy and we want to get 85, as you iterate through it, you should be tracking that, and that becomes your explainability interface. So when you sit down with your data science manager, your data engineering team, or your stakeholder, you can tell them, here's the 10 iterations I did with this development. Here's where we did the best. Here's what we think the inputs to that success were. And here's where we think we could alleviate it downstream. Because the idea is you want to, one, learn from your own mistakes, but secondly, and more importantly, you don't want to repeat your mistakes, because then, how many times do you repeat a mistake before it becomes a choice? And that's kind of the idea behind explainability is, how can we have a low overhead, high impact workflow that's going to augment your work and not detract from it? Because explainability and data science are complex topics, and you don't want to address a complex topic with a complex solution. So now that we've kind of got some definitions out of the way and the higher scope, this is kind of the global viewpoint of it, at least from my perspective. So we're going to define explainability as the ability for a data scientist or an IT professional. I saw in the comments that there's interest in data engineering, things of that nature, results to be understood and interpreted by other data scientists and stakeholders. So at the end of the day, the onus of responsibility does not fall to you per se. It falls to the one you do your work for. Because as a data scientist, your work is not directly fulfilling to the extent it's what it's not necessarily what you're doing. It's what you're doing for the business at large or for your team at large. Because an individual's data scientist work is only as powerful as the data they have access to and to the scope that they have been addressed. So it's really important to keep that in mind, is that are you building something that's going to be deployed in product? Is it important that end users are able to, adequately, serve themselves? So an example of this, where explainability arises, is in banking applications. So like loans, there's disparity between the way men and women are able to receive lines of credit. And the problem with that is we're able to observe the issue, but when we try to address why this issue actually arises, we have a hard time parsing through that. We're not, and the indicator of an unequitable outcome is the idea that a man and a woman with the same input features other than their gender should receive the same line of credit. But when you look at the model and the outputs, that's not the case. And so figuring out why is, what we kind of defined before. You would, statically iterate and interpret your outputs, and then you dynamically explain, hey, out of the 5 models we built, the one that gave us the most equitable outcome with respect to gender was this one. And then you hopefully have done enough work and enough commenting and reporting to adequately explain to your stakeholder and your end user why this one is the best one. Otherwise, if you're not keeping track of these and reporting it, it quickly becomes like, this model gave me the best accuracy, so we should use it. And you'll quickly learn that the data science teams are moving away from that perspective. They're moving towards more trusted and transparent workflows, because there are costs associated with, model redeployment, data drift, having to pull a model offline, even if it's only for a few hours. That can cost your team and your business a lot of money and a lot of time. So it's best to circumvent that when you can. This graph is basically, it's has 3 axes. It has an x-axis, a y-axis, and a z-axis, where the x-axis represents experience, y-axis is technical skill, and the z-axis is a need. And you can think of this as like a bounded decision space for your business. And in this bounded decision space lies all of the different personas that you as a data scientist could serve. So as you can see, you could have a data science manager who has high experience, high technical ability, and high need. And by need, we mean need for explanations. And then you have, another data scientist who may have less experience, a similar amount of technical fortitude, but less need. And as you can see, we've put regulators, end users. The point of this graph is you really want to understand what is your work serving in the greater scheme of things, and kind of converge on that. So what you shouldn't do is, as a data scientist, you shouldn't build one product that caters to every single persona. That's not necessarily your job. Perhaps your team could work together and try to cater to each persona, but I would say it would be a poor use of time and resources for one person to hold themselves to that standard. And that's why this is a team effort, and that's why it's called an explainable workflow, because you're really going to need to you're going to need to not only apply this to your work, but apply it at a medium scale, I would say. So your whole team is working through this workflow, so that way you guys can make sure everyone's on the same page. And by doing that, you can quickly transition to having these very dynamic and iterative loops where you can quickly debug and things of that nature. Okay, so now we're going to go into like a brief coding example. So this is the Portuguese banking data set from UCI. It has, numerical features, it has categorical features, things of that nature. I can send you guys the link if you want to look at it. I also have like a GitHub that basically has a long form version of this talk through code. So I can send that to anyone who's interested. But the problem associated with this data set is to classify if our users will open a bank term or not open a bank term. Classification versus prediction is another facet of explainability, but it's out of scope of this talk. But if anyone wants to talk about that, once again, I'll leave my email at the end. And then the second, the secondary goal of this is to identify our principal factors that contribute to each classification. So, what are the three features that are going to determine, what are the three most likely features to determine whether or not someone is going to open a term with us or not? And that's important because that allows you to, indicate to downstream tasks and et cetera, et cetera. So here's the code. It's not too crazy, I promise. What this is, so this code is making the assumption that we've already done our data pre-processing, our feature engineering, our correlation tables. That's all represented in the GitHub that I just alluded to. But I didn't want to take the whole talk and just show you guys code. I just want to show you the important parts. So this is an explainable workflow because it's a workflow. It's not just not a single step is explainable. The idea is all of it should be explainable. So we did feature engineering. We removed correlated variables to a certain degree, things of that nature. We did feature transformations in order to make sure that we're reducing multi-collinearity, et cetera, et cetera. But really, what this is telling you is the explainable pipeline. So in line 14. Basically what we're doing is just very similar to an sklearn pipeline, just uses different nomenclature. But what it's saying is, hey, take my data, do no operation to it, do no transformations, do a PCA to it as well, which is, I'm not going to go into that, but it's a principal component analysis. Do these two things, concatenate the features. So if I have 15 features going in, 15 features go in, we do a PCA, and then we have 15 features that nothing was done to. We can concatenate them, and then the second part says, do a logistic regression, do a k-nearest neighbors, and do a decision tree. And what it's going to do is, in the next line, now that we have this pipeline built, auto configure is basically, if you've heard of SMAC or hyperopt CV, things of that nature, what it's doing is it's automating your hyperparameter selection. So what it's trying to do is configure the optimal hyperparameters based off of your scoring metric. And for our scoring metric, we decided to use accuracy. You can use any of these scoring metrics from sklearn. You can custom create your own. That's not really the scope. The idea is that you can test a suite of algorithms and quickly determine which ones are going to be the best for you. And the other thing is that I'm trying to demonstrate here is these are all relatively simple algorithms. These aren't neural networks or anything like that. This is a logistic regression, k-nearest neighbors, and decision tree. The idea being behind that these are directly interpretable, meaning, you know, a logistic regression will give you coefficients that indicate the strength of each term. A Cade nearest neighbors will, you know, you can put that on a graph, and you can put that in a 2D graph and show where does each decision lie on this graph and how are they clustered together. And then the decision tree, you know, you can evaluate the Gini index and things of that nature. How many splits do we have? Where does the tree end up? Things of that nature, versus using more complex algorithms. We can visualize it. So you see PCA, no-op, concat, tree. So our optimal algorithm ended up being a decision tree. We're able to print out our feature values. So in line 17, you see our hyperparameters, our pipeline, and the hyperparameters behind our PCA. What's important to note is this is reliable and stable. And what I mean by that is you could output these hyperparameters as like a .yaml file or you know, a JSON file, what have you, and then you could share it. And then it's also reliable and robust because I think it was called Deep Note. The idea being like that integrated Jupyter notebook that George showed in the data dump. If you guys were using that, the idea is if I run this pipeline on my computer and you run it on yours, we should agree upon the same suite of hyperparameters within a degree, you know, within a certain mathematical degree. But what I'm trying to say is if you put in the same inputs and run the same pipeline, you should achieve the same results, which is very important because if you've done code before, you can realize very quickly, I can do the exact same thing as you on my machine. And sometimes it does not come out the way we expect. And then the last thing I'll leave you with is the accuracy we're able to achieve is 69%. Without contextualizing it, that's not very important or fancy. But what's important to know is the state-of-the-art accuracy for this data set is, I think, 74.5%. And we were able to get, you know, just, you know, 6 percentage points shy of that using a decision tree and, you know, 5 lines of code. You know, and this is a research paper that came out from an academic institution. And that's trying to show the power of the explainable workflow. And that's why it will augment your workflows, because as you can see, these 5 lines of codes could quickly be transitioned regardless of data types. You change the algorithms based off of, you know, what kind of output you're looking for. And this allows you to quickly, like we said, iterate through different algorithms, identify which ones are going to be worth the time investment, and then you can do more diagnostic testing, you know, after this step. And, you know, I didn't show the code, but basically there's just like you just iterate through a Python list and it'll print this stuff out in a very pretty way. But what this is going to show you is for an individual observation. So for, you know, if this is a CSV for a single row and all 15 features, this is going to show you if we take these 15 features, what is the classification odds? So is it, you know, class 0, class 1, and then what were the contributing features? And what this is saying, and just a little bit of math, since it's a binary classification problem, the log odds, which is these numbers next to duration and year, bore, 3M, things of that nature, they're inverted for each class. So if a duration, which is the duration of the telemarketing phone call to a person, if it's less than 100 seconds, the person's not likely to subscribe. If it is more than 100 seconds, they're likely to subscribe. And so as you can see, this is important because what you can tell, you know, your campaign team is, you know, as you iterate through this, it's like, hey, the most significant contributing factor to someone soliciting stuff from our bank is whether or not they're on the phone with you for more than 2 minutes. And that's the idea of explainability is not only can you give them the output of, hey, these are the people we expect to do it, but, you know, kind of give them an indication of why. And then this last step, this is just 2 metrics from, this is, by the way, this is Lale and AIX360. They're both open source tools from IBM. I have the GitHubs in one of these slides. But what this is showing is because when you use an algorithm, some of these algorithms, they create ad hoc models, which is basically, if you have model A, we create a model A prime to simulate the experience of your original model. and that's how you compute these graphics. The problem with that is that faithfulness metric that represents, do models A and A prime have similar compute? And what I mean by that is, like, do they follow the same like transforms? Do they do the same mathematics behind the scenes? And then what monotonicity is if you have features F1 through Fn, are they additive, monotonically additive? Which that means is if I have feature 1 and that contributes 10% accuracy, if I had feature 2, will that increase my accuracy? If all the features I include give me a monotonicity value of true, that indicates that I did feature engineering pretty well, because all of my features are imbuing some kind of information into my model. I can go more into this if anyone has questions after the talk, but I see I have 4 minutes left. This is a research overview of different papers. I have all these in PDFs and they're on Arxiv in case anyone wants them, but Stop Explaining Black Box Machine Learning Models. That's from Cynthia Rudin at Duke University. That's a really good one that kind of, it shies away from neural nets and things of that nature and says, you know, you could use rule-based algorithms to do a lot of things that neural nets are used for. We have the XAI program update from DARPA. Why should I trust you? That's the Line paper. Type-driven automated learning with Lale. That's from IBM. Towards robust interpretability with self-explaining neural networks. That's a integrated gradients. That was out of scope for this talk, but that's how do you make neural nets more explainable? That's from MIT. And then the TED paper is also from IBM. This is where the demos live. I'm pretty sure they said if you go to meetup.com, you'll be able to get these slides. So this is, there's the GitHub for Lale and AIX. And then there's also a masterclass that I built out. It's like an hour and 15 minutes of content. It's still up. It's free. I'm pretty sure you just sign in with an email and it'll be a much more descriptive overview of this talk. And it has, code patterns in it as well. So yeah. I thought I'd remove this slide, but yeah, this is what the site looks like. And then this is the bibliography in case anyone wanted to look, but it's just the papers I listed as a research overview. And that's all. So I think I have 2 minutes left. Sorry, I almost used all my time just talking. But yes, so I think I can stop sharing my screen.
Oh, I'm back. Oh, we're all back.
Yeah, we're all back. So I'm just going to share over the screen. So great talk. Really enjoyed it. What do you have to say about this one? I'm going to be looking for some questions while we speak.
Yes, we can actually pull out the latest one from Brian. So
I like
his question. Yeah, it's a long one.
Yeah.
Yes.
So
sorry,
you want to read it up? Yeah.
Yeah, from your experience, after you trained a machine learning model using some complex black box models such as CNN or LSTM, how do you explain to the business stakeholders and convince them that it works better than the classic machine learning models? And I would add to that rule-based models as well that they've come up with.
Yeah, so there's existing literature on this. So like I'd recommend if you want to read like a really good one, there's prorepublica.org. They did an evaluation of a proprietary algorithm that would do like, basically it would see if people were going to go back to jail or not, and it would discriminate on people based on their race. So they did a lot of evaluation metrics. The reason I bring that up is because when you read in how they did it and how they went through their analysis, it blends itself to your question is, as a data scientist, I mean, it depends on how much you interact with your management team and stakeholders. It's different at each business, but you kind of have to think of yourself not only as a technical member of the team, but you're also kind of like the storyteller. So what I would do is if I, like in your example, if I'm using a black box model, such as a, convolutional neural network or an LSTM, what I would try to do is, to the best of my ability, elicit to my stakeholder, what are these algorithms doing in layman's terms, so long short-term memory, like what does that actually mean? Like these are a suite of algorithms that are meant to address the complexity of sequential models. What does that mean? And so the idea is you would iterate through this by yourself, and eventually you should be able to write out a paragraph and be like, hey, I think we should use LSTMs because these are sequence models, and we have to have respect to sequential order. The problem with that being is the length of our documents are so long that we lose context from the beginning if we use typical RNNs or recurrent neural networks, things of that nature. And so as a data scientist, I'm recommending to you, we should use this because I think it addresses the three problems we're most likely to interact with. And then you go and do it. And, you try to solicit as much feedback as you can, try and stay cogent of what you're doing. But I guess the underpinning of what your question actually is saying is like, how can you adequately relay this? Because eventually you're going to probably hit some wall. And that's where I guess my ultimate recommendation is you probably just need to sit down with your team and see, is it worth the time, and what is the time investment in dollars of educating people on these subjects versus doing it. And that's a problem businesses kind of are facing right now, and they're addressing it very ad hoc. Sometimes they'll bring in consultants and things of that nature, but it's, how much is it going to impede your team if you're not able to use complex models because your team can't adequately relay why, versus just kind of the current trend of using state-of-the-art models. So sorry, that's kind of a long-winded answer, but what I would do is I'd really try and find a robust way in like 5 sentences to explain why we're using it. Because if you just go to your manager and just talk about the model, that's probably not going to go over well. Because then you put yourself at a disadvantage, because they may ask you a question that you weren't prepared for, and if they ask you, okay, well, what are the 3 assumptions of a CombNet, and you only know 2 of them, that makes them a little bit more apprehensive, because they're like, oh, my data scientist only knows 2 of the 3. Should we really use that? So you want to make sure before you go and talk to your manager, you frame this, you educate yourself, and you go to them and tell them like, hey, I don't know everything, but I'm trying to know enough to make sure that you understand this is important, worthwhile, and it directly relates to our KPIs or business value or et cetera. Sorry, that was long-winded.
A little bit.
Okay, this is a very important question for a lot of us to relate to anyway.
Yeah, I think that we've got a few interesting ones. Do you think I should bring the one about RHC up? Sorry if I'm saying it wrong. But
you're going from bottom up, right?
Yeah, because they came in and they're like, oh, super relevant now, so I just wanted to bring this up before we go back up. Yeah. So this question is basically, can I say the explainability of AI model correlates with reproducibility?
Oh, this is so good.
Yeah. So one of the papers I linked to directly approaches that. It's the Cynthia Rudium paper from Duke. I can send it to anyone who's interested. But I do think that is they are correlated with each other. The idea being, if you can adequately explain your model's behavior, that means you understand, a lot about it. Data ingestion, the internal assumptions, and if you can explain that in like terms, then that's correlated with the ability for you to hand that off to another team and educate them on its usage, and then they can reproduce your results.
All right, great. I'm hoping that one answers your question. So we have another question here from IS2, I think. So, could you share an experience you personally had in your work explaining your workflows and models? Because a lot of people like all these war stories.
Yeah. So a specific instance that I'm trying to think of one that I could say pretty quick. Okay. So one I had is I had a disagreement of the value of data. So it wasn't so much on the model side, it was the workflow. So I was trying to access data that didn't necessarily belong to my business unit because I believed that it was the information we needed. And I quickly realized that I didn't have the scope to adequately relay why it was important and why it was worth the financial cost of obtaining this data. And because of my inability to make that well known, it took 3 months to get the data, and then we got the data, and I ended up actually kind of being right, and it worked. The problem with that being is there was a 3-month delay between when I thought it would work and when I could convince management to let me do it. And just that costs a lot of money. So that's a specific example of like why, like even from just like, why do you need this data? Having an adequate explanation before you make the ask is really important. So that's just one specific example I have.
Right, thanks. Going on, there's another question here that relates to the result of explainability. Basically, when you wanna do this one?
So the result of explainability.
Okay, so
Oh, go ahead.
Yeah.
no, it's fine. We're just all reading the same. So yeah, the result of explainability is a conclusive report for the stakeholders. I think this is more like output focused.
Yeah.
So what do we get out of this?
Yeah, I would think of like explainability is it's the README of a GitHub. Like when you open up TensorFlow's GitHub repo, you immediately know what it's about, like immediately, and they from the way it's framed, you immediately know like, wow, this is built by like really educated people. It's stable. The work's been done. They show you all of their code bases, all of their refactors, everything like that. And like, yeah, that would be the explainable output, is like you're able to track, measure, and understand the progression of the product. So like in a business setting, it would be, so like your end of work report, so like I'm not sure if you've done it, but like when you work with contractors and things, like you scope out the work, then someone makes sure that they did the work and it agrees to what you gave them money to do. And then at the end, they give you a report, like a debrief of like, hey, here's what your expectations were. Here's how we met them. Here's how we made sure we met them. And here was the results of us meeting your goals. So that would be the output. What's important to note is that output should represent the business ask. And if it doesn't, that tells you something.
All right, awesome.
I think we have one more. We have one more from Alex, actually. He's just asking if all machine learning models are interpretable.
No, not. I mean, a caveat is what do you define as a machine learning model and what you differentiate as non-machine learning, but not all of them are. So like there's like a suite of algorithms. So like most, not all of them, but most regressions can be thought of as being not all regressions. Sorry. Yeah, I guess the answer is no. Some algorithms are more interpretable than others. So like decision trees, if it's a small tree, you can display that and like visually inspect it. And, you could follow the path of like, my data comes in, I follow the tree, this is where I end up. More complex algorithms aren't necessarily going to give you that level of interpretability out of the box. Even if you do use a directly interpretable model, if you use some fancy pre-processing techniques that might transform your data into a non-human interpretable format, which directly impacts the interpretability of your interpretable algorithm. So I would say no. It'd be an unfair assumption to say all machine learning algorithms are interpretable. That being said, there is a subset that are. And that's addressed in two of the papers that I linked, the neural net paper and then the Duke paper.
All right, awesome, thank you. I think that's all the questions we're going to take for now. Want to move it along into the Zoom call, right?
Yes. Later we can, continue asking him any questions you would like. That's even like beyond explainable workflows. So right now we've reached the end of our session. So thanks again, Austin, for an insightful sharing, especially for waking up this early. Hopefully we can all move towards explainable workflows and models. So once again, reminder, don't forget to fill the feedback form. And I hope to see you guys in 5 minutes for our post-event hangout. I just realized that the link might not be in the description, so I'm sending it in the comments now. So yeah, it's like please join us. You can ask both like Austin or Tim anything. So slides will be posted on the Meetup group. So thank you all again for joining the stream, and we look forward to seeing you later.
Right, we'll see you guys
Bye, guys.
in 5 minutes.
Yeah.
Thank you.
Thanks, everyone. Bye.
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 Right, I'm just going to leave the stream up for a bit more so you guys can use the QR code, but we'll be ending the broadcast in a bit. Yeah.